All right, cool. So this is my project. I just named it Project Memories. It's my final project for this VR class. So my idea was to create like a shared social space where users can experience different memories in VR, and each memory is basically like a short 360-degree POV video clip. And I thought that was interesting because like high quality POV videos in VR, if they're done well, can really like transport you in experiences that you normally wouldn't be able to see. So users would be able to like share and rate different memories and upload new video clips. So with this project, you'd be able to see Amsterdam or go skydiving or do anything that normally can't do when you're stuck at home doing schoolwork. So those goals were the project idea is a little bit too lofty for the scope of this class. So I had a specific goals I wanted for this project. So for this demo, I just wanted to do like a simple interaction demo that conveys the mechanics of the original idea and kind of focus on like the memory playback experience, networking in a shared social space in Unity, especially since I'm not a Unity developer and I had no idea what I was doing half the time. That'd be like a project on its own. So, and also I wanted to learn and implement different VR systems like local motion and interaction. So what you see is again, everything was built with Unity 2020 using Unity's XR interaction toolkit and was developed on my personal Oculus Quest 2. All right, so here is a little gameplay demo. There is no sound, so don't worry about that. So
So
basically you're in
your
this
slides are not going, you're on slide 1 still, are you there?
Oh, yeah, can you hear me?
Yes, but your slide is slide number 1. Did you ever change
Oh,
the slide
no.
number?
Oh, let me just back up. Can you guys see the slides? Are they
Now
moving
we
now?
can see.
Oh,
Yes, now
okay.
we can see.
All right. Well,
You
I'm not
can,
gonna.
yeah.
Was that?
It's okay. Continue.
Okay. Yeah. So those are the slides. I'm not gonna repeat everything, but I just basically reiterated each bullet point. And so yeah, back to the demo. Can you guys see that?
Yes.
Okay, cool. So I'm going to play the demo. There is no sound, so don't worry about that. So basically, you're in a VR world, and all those little blue orbs are like little memories, and they have little physics, just basic physics attached to them. And then you also have teleportation, and when you grab an orb and activate it, you can get transported to a different memory, which is a 360-degree video player, and then you can kind of experience like a little snippet of somewhere else. I actually don't even know where this video is taken. Also, I implemented basic video controls, and then when you activate it again, you can go back to the virtual world that you're at. And the rest of this demo is I'm kind of just playing around with the physics and experiencing different memories. And yeah, so there's also have a snap turn and continuous movement that I implemented in Unity. So this is the last memory, and then the demo will be over. That was my project. So what I did get done for this project is I was able to implement hand presence, custom hand animations, snap turn and continuous movement, teleportation, universal render pipeline, screen fade. So like when you teleport, you can see the screen kind of goes to black. And that's also how I fade between scenes. And then a 360-degree video player, as well as really basic video controls. So for hand presence, I just used the Oculus model for the mesh, but I did animate all the fingers individually. So for the Oculus controllers, there's really only 2 buttons. So basically for the grip button, you close the first 3 fingers to kind of make the L. And then for the select button, you will get the full fist. And then so it just animates between those 2 states on each finger. And I also had a snap turn and continuous movement. So this was actually pretty easy to implement because the XR toolkit has a bunch of scripts that you can apply to your XR rig object. So I just had to hook all those up and get it working. And then it'll also work with like character controllers objects on Unity as well. Now to add teleportation with screen fade. So this is the same screen fade that I used to fade between scenes. So originally I had like just like a big canvas object that would fade the alpha in and out, but it was really buggy. So then I did a lot of digging and I finally was able to write like a custom little shader that I could plug into the render pipeline, and it would just render the texture alpha like up and down, and then that's how I got the screen to fade in and out. So that way, when you're teleporting, isn't like a super snappy jump, and it's kind of smoother. And then the 360-degree video player, basically, it created a new scene and then added a video player with a render texture, and then rendered that onto the actual skybox. So what you're seeing is just a skybox and just kind of moving around in space. And it's just rendering the video straight to the skybox. Some other features that I worked on, but I didn't get to finish because I'm not a really skilled Unity developer, is one thing I really wanted was like physical hands. So your hands would have physics, would be rigid bodies. So I did attach rigid bodies to the hand models, and I tried to have them follow the XR controller around with velocity movements instead of just messing with the transform. And it did kind of work, but it also mostly didn't work. So I ended up cutting that out for the demo. Another thing I was working on was automatic hand posers. So if you see in the demo that basically whenever you grab something, your hand disappears. That's just kind of my solution for not having your hand be rigid the whole time. So what I tried to do was add colliders to each joint on the finger. And then whenever you would grab something, the object would snap to the palm, and then your finger would go through the close animation. And whenever a collider interacted with a different collider, it would stop the animation. So you would end up getting like a nice dynamic close animation. But that didn't work either. There was a lot of bugs. I kind of got it mostly working, but there's a lot of different problems with that. Another feature I was working on was gesture-based video control. So I wanted the user to be able to like swipe left or right with the controller, and then the video would seek fast forward or rewind. And that was difficult to implement as well because it really wasn't natively supported on the video players that Unity has. Pretty much have like start and stop. And then also wanted to be able to support different video formats, like not just 360-degree, but maybe like a 2D video player that could pop up. But again, I ran out of time for all those features. So lessons learned is I learned that game development is hard, and VR game development is even harder. I felt like I didn't know what I was doing the entire time, but it was really fun learning experience. I got to learn a lot about Unity, textures, materials, scripting and C# and all that stuff. And what I would do next time is just kind of evaluate what systems I actually need and then allocate blocks of time to develop it. I kind of spent way too much time trying to make hand physics work and dynamic hand posing, and those ended up just not working at all. So I just had to kind of scrap it and then move on with what I could implement in my ability. And then also finding quality videos in the correct format was a challenge, but we're able to find some that I think were high enough.
Okay. I figured I'd show my video very quickly just to say that I am a real person, since I'll be doing a live demo of my application, and I'm going to turn my camera off when I do so you don't have to see me wear VR goggles. So let me screen share and jump right into that. Let's do this fast now that I just lost a bunch of time. I'm Andrew Wilson. This is my final project, and I primarily wanted to focus on implementing some basic VR functionality with the stretch goal of doing some gesture recognition stuff, which we'll get into in a moment. But I found that just setup was really hard, like to begin with. And I first tried to use the Oculus integration, the official integration, and the Oculus avatars, which makes great hands and they're all animated. But then I couldn't really get anywhere from there. So I switched to using the XR Interaction Toolkit, which is cool because it is hardware agnostic. So everything you see here, in theory, should work on anything or any piece of hardware, not just the Oculus Rift that I have. So using the Interaction Toolkit, there's some built-in components like locomotion systems that make it easy, quote unquote, to do things. And so I was able to add in hands with animations. So with triggers, you get this nice little pinch animation. Grip buttons, you get this nice grip animation. And like I said, trying to add locomotion. So for the right stick, I was able to implement snap turning. So we get a nice little 45-degree turn here. I have pretty good VR legs, but continuous turning is always the thing that gives me the most motion sickness. And so with the left stick, we can glide around like we're VR ghosts. And of course, you can combine these two things together and move around nicely around the space. The third pillar of movement, of course, is always teleportation. So I have that implemented as well. If you click either thumbstick, you get this nice little fishing line ray with a reticle for where you will appear. And so if you let go, you can teleport with either hand and jump to that spot. And you're able to actually designate what space is teleportable to. So this whole ground texture you can jump to, but you can see this little staircase object. It's red. It doesn't let you teleport there. Likewise on this little counter, it doesn't let you teleport there either. And so once I had locomotion working, the next thing to kind of add that presence of VR is to actually interact with your body. So if we go up the stairs, we actually see the height change. And if we go up off the edge, we fall to the ground. So we're affected by gravity, which helps, protect that illusion. Likewise, we can't walk through the counter. After movement, the next kind of layer of things to add or that I implemented was grabbing objects. And so this again is something that is enabled easily through the interaction toolkit. And you can see the hand disappears when you grab something, which is a quick workaround to not have to have holding animations for everything, but you can throw the objects around, which is cool. It also gets a little tricky because you can specify velocity of when you throw stuff, and you can kind of like mimic the mass of things that way. But for now, I didn't play with it too much, just to kind of proof of concept, the fact you can throw objects. And that's going to be over there. You may have noticed this little floating book here. So coming back to my stretch goal of gesture recognition, when I think of VR, I always think of like, it would be so cool to be like a VR wizard, right? And be able to cast spells with gestures through the air. And if you played any games of that theme, it's a common thing. This is nothing new, but I thought it would be a fun goal to try and implement something like that. So if I pick up the book, if we let go, it actually snaps back to this belt position, which took me a very long time to figure out how to do. And in general, I found working with transforms and 3D coordinates a little unintuitive in Unity, so it took a lot of trial and error. But you can see it always snaps to the same orientation. And so it's like you're holding the book on the spine. So with book in hand, if you click the trigger, you see these sparkles start to appear and trace your hand gestures in a fully 3D space. And when you let go of the trigger, it tries to recognize the gesture that you just drew. And I ended up using a point cloud recognizer that worked in 2D space to do this in the project. Now, the caveat is that we can draw in a 3D space and it's a 2D recognizer. So what happens when the script executes when you let go of the trigger is it actually casts the shape to your screen plane, which is a 2D plane. And so as long as you draw the gesture roughly flat, it actually works super, super well. And I pretty much had no issues recognizing. So that said, let's see some gestures that actually work. So assuming you're holding your spell book, quote unquote, you click the trigger and draw a upside down triangle. We get this nice little fireball particle effect that floats in your hand, follows it around, and the sound effect is actually spatial. I don't know if it actually is that obvious, but if you move it to the left and right of your head, the sound changes direction. We don't need the book for this. Once it's in your hand, if you click the trigger, it'll shoot out, cause an explosion. It'll apply some radial force to knock the objects around. Makes it look fun. There's a couple different sound effects that play. I wanted to try and implement 2 gestures or 2 spells. So besides the triangle and the fireball, if you do this little swirl animation, we get this nice looking wind particle effect around our hands. And if we let this one go, it's a surge of force, and it actually creates this persistent wind zone. If we grab one of these objects, it actually gets propelled by the wind. And likewise, if we do it again, it also affects little fireball we can summon here, which is very cool. For the most part, that's all I was able to implement, but I was super happy with how all the gesture recognition worked out, and the particle effects I was able to play with. Obviously, there's room, to expand this into actually something that would utilize all these features. And I found I really enjoyed playing with like particle effects and stuff and making things try and look nice. I kind of made the mistake of using the universal rendering pipeline for my project instead of the default 3D template. And on one hand, it was very cool because it let me have those awesome particle effects for like the hand effects. But for the most part, none of the assets, the free assets at least in the Unity store, are set up to work with the universal rendering pipeline. And so I was very limited in what I could use. Sometimes you're able to upgrade them, which is what I had to do for the book, but you can see the textures don't work quite correctly. But instead of redoing it, I just trudged on and focused more on the gesture stuff. But yeah, I'm really happy with how it turned out, and I'm glad I had the opportunity to develop in VR. Any questions?
Okay, so I made a VR music visualizer, and it turned out kind of cool. I wish I'd started a little bit earlier though, so I could have had more time with it. So I have a little overview, just the tools that I used for it, and then like towards the end, I kind of discovered better tools that I could have used, but they're more advanced, but I'll cover that a little bit. And then I have a demo video, bit under 2 minutes. Oh, also, if anybody's like sensitive to flashing lights, that's basically like my entire project. So towards the end, I have a little bit in there, and then the demo video, you may not want to watch that. Okay, so my idea was like a music visualizer that you can move around in VR that like different objects get like controlled by the music. And the way I would do this, sorry, my cat has decided to live in my room and I'm a bit allergic, so my throat gets really itchy. So the way I do this is to take the songs as they come in and filter them into like different frequency chunks, and then like use those different chunks to automate, I guess, like various features on the objects. So I made just like a little VR area, like a secluded valley, have some mountains here, just like terrain that was raised, some rocks also to make it look not so bad when you're down there. Little floating cube in the middle, and then you can see this square area here is like a teleport area with Steam VR. The trees and rocks, a few of the rocks at least, they like move with the music. It looks really bad, but it was kind of the first thing I did. Then also the light, it's kind of dim. It's like the evening. I have a night sky in there, and then when music plays, it gets dark. So yeah, I use Steam VR for it. It's at first I tried using like the Vive stuff, but I'm sure you could do more like personalized things with it, but it was like a real pain to get set up. So there's a Steam VR plugin, which it's really nice. It has like everything already done for you more or less. You just have to like pick what you want in it. Has a lot of examples and stuff too. So I basically just did that for like the camera and teleportation. It was pretty easy to get set up once I knew what I was doing, thankfully. And then I found a tool called LASP on GitHub, which is it's kind of just like a basic audio, like live audio tool. It converts audio into kind of just like the average volume, I guess you'd say, into a float between 0 and 1. And then it has like just very basic filtering on it for low, band, or high. And then you can use that to connect like public properties of objects to it. So then you specify like if the value is 0, like what it'll be at, and then if it's at 1, which is like max audio, what it'll be at for that. That saved a ton of time because the FFT algorithm, which is what you use to convert like chunks of music into like a frequency spectrum, it's just very complicated. So definitely didn't want to have to implement that. So after I did like the moving trees and rocks, which was awful, so I moved on to just like basic particles, and you can kind of see them here. They're just like little colorful dots that float around. And so they flow down from the center near where the cube floats from. And they move around and get like a little, like they're really small usually, but I think right here, this is actually like while music is playing. So they get bigger with the bass, and there's a particle force field used to just kind of like spread them out as they fall down. So then I added some fire on some of the peaks of the mountain there. This is actually like the Unity particle kit that they have for free. I think Unity made it on the asset store, and it was just like the flamethrower plugin. So it's also connected to the base, as most things are, although it's not as sensitive, so it's more just like kick drums or like really loud bass. So the big thing I got to, I went back to the particle system, and I got some floating cubes that just kind of like slowly spin in different directions, and they shoot out little like light ray particles from the little cube in the center there. So the amount of particles that shoot out is connected to the high end, which ended up being like mostly vocals and synths, also like snares and hi-hats on drums. There's a particle force field that makes them spin around the cube in the center. And then, so there's like a one ring that when they reach to, they start spinning around, and then they like slowly drift out to the side. And then when they reach the end, they just kind of like disconnect and float away. And so the distance, or I guess it's more like the size, is also connected to the base. And so it'll like kind of pulse out and shoot them out faster, or just move them closer to the edge. Yeah, that's kind of what I just went over. So you can kind of see here, like they get shot off when there's music playing. So it's limited to like 800 or maybe like 1,000 particles, which looked cool and didn't cause too much performance issues for me. But if you had like, I tried like 10,000, I think. And if you guys have ever seen like the steel wool thing where you light it on fire and spin it, kind of looked like that. It was pretty cool. So here's like a kind of like an over the top demo that you can see with the particles that are like kind of constantly coming out and forming that inner ring, and then like slowly drifting out to the side. But then they kind of get like shot out when bass and music plays. So I just use like the default particle system in Unity, which I mean, it's just called the particle system, and then particle force fields. And it's pretty cool. Like you can get like some cool results from it. Here's a few pictures. Just I looked up Unity particle system on Google Images. I mean, you can get like lightning, you can do fire, whatever that thing is down there. It's cool, but like kind of basic. So kind of towards the end of my project, I stumbled on something that came out like a year or two ago called the VFX Graph, which as far as I can tell is like, I guess just like the next particle system upgrade. So this is just, I looked up Unity VFX Graph on Google Images and got a bunch of examples here. So like, as you can see, like they just look way cooler. Like you can have way more particles in them. You can chain a bunch of effects together and do cool stuff with it. I mean, there's some really complicated stuff online. One of the big things though, is you can make custom like 3D objects that the particles will like interact with. I think they're called like vector fields. And so you can kind of choose like where the particles, instead of like a force field where you're stuck with like a circular shape, I guess, you can make like your own shape and like choose like how fast they go and in what directions. I mean, it's like a cool example of that would be like if you made one of these maps down here and had like down here, I think they have clouds that like move around on the terrain. And then it can also just like take shapes like the cubes or a person. So I did not try any of this. I looked at it for like an hour or two, and I mean, it was pretty complicated, but it looks like if you did learn it, there's like some really cool stuff you could do. So the last plugin that I used was from this guy named, I think it's like pronounced Kjiro. So he has a ton of repos on GitHub, 611, and if you search Unity in them, there's 390 that come up. So he does a ton of like open source Unity stuff, a lot of it like visual effects related. I think they actually work for Unity in Japan. Not positive on that, but they have that on their GitHub. So, I mean, if anybody was like trying to find cool VFX graph ideas, there's a lot of them on there. All right, I got a short demo video for you guys here. Just a few different songs.
And now I'm feeling numb, blind with your memory. How do you let go? Ooh, I need your love and pain, but you're cast away. Going down for real. It's going down for real. It's going down for real. Where are you now that I need you?
All right, any questions?
Okay, so I didn't make a PowerPoint for the presentation, but when I got started with the Unity project, one of the big things I noticed was I couldn't do smooth locomotion. And because of that, it's kind of hard to move because I don't really have a lot of physical space to move in. So I didn't really think that teleportation plus real life movement would allow me a lot of flexibility. And there were some tutorials online for doing smooth locomotion, but the one that I found, I wanted to kind of write my own code because what they had just had you move forward, and it ignored the negative values, so you couldn't walk backwards, or you couldn't strafe. So there's a SteamVR action vector 2, and then what that does is the code here goes and it calls a function in the SteamVR plugin for Unity to go and get where the HMD is looking at. As long as you're not flying, which I disabled because if you fly and then you fall, you'll get sick from motion sickness. So it will set the y-axis to 0, and then it will add the x value on the analog stick and the y-axis. And then it will also do a raycast to make sure that you don't walk into a wall. And if you have an object, both your hands and any object in your hands, that would be counted as a wall, so you couldn't walk forward if your hands were in front of you. So I made a layer in Unity to go ahead and have the hands. And I added those to the hands layer. And then in the hands script, when you pick something up, it gets added to the hands layer so it doesn't get counted against what you can't walk into. And then it goes and it's kind of calculates the hypotenuse to see how far the stick radius is. It takes the x square plus the y square, assuming it's greater than a dead zone. Because if you have a bad controller with stick drift, which my old ones did, then you would have a perpetually moving forward. A lot of Unity games like Budget Cuts had problems with this, and they patched out later by adding a dead zone. The dead zone in the player is 0.2, so at 20%. And then it square roots the hypotenuse, calculates the speed by it. And then Once you get that, another issue I had was it wouldn't let you snap turn. I think snap turning only let you snap turn every, I think, 0.25 seconds, and I changed that to 0.1 so you could snap turn. And then I also commented out this whole chunk here because it wouldn't let you snap turn when you were holding something, which I found to be very limiting because in Half-Life Alyx and other VR games, you can snap turn when you hold something in your hands. But you couldn't do that out the box with the plugin, so I had to comment this out and just set the booleans to true, so it's always valid. Then Patrick wrote this gun script. Do you want to talk about that, Patrick?
Yeah, I can jump in here a little bit. So originally our idea was to, everyone can hear me, right?
I can hear you.
Okay. Yeah, so our original idea was to try and remake Portal in VR, and there was a whole bunch of issues with that when I was trying to implement it. Just multiple camera angles and then trying to render the extra angles onto the portals, and it just added a bunch of complications. So we ended up morphing it into this. But basically the guns, you can pick them up. They shoot different missiles. Originally, I don't know how far we got in this, but I started making it so that you could use them as booster rockets, but then I think we decided not to do that because trying to use booster rockets and then falling back down was going to make people motion sick. Yeah, just a lot of like moving things around to make it look proper. I was originally trying to make it so that your hands would still show gripping the gun, but then it turned out to just be easier to make the hands disappear when you're holding a gun. Yeah, I think that's about all I wanted to say about the gun scripts.
Okay. Cool, and I think I did experiment with trying to get some sort of actual stakes, because all the demo is you can just walk around and shoot things, but there's no way to die, there's no objective. And I was trying to see if I could modify the hand collider script, which already has an on collision enter, and then log when there's something that touches your hands. But I never really implemented any actual consequences of touching something that isn't in the hands layer. So there's really no concept of player damage, no concept of death. It's just walk around and you can shoot things. So let me see, I'm starting it up. So you probably don't, you can kind of see it there. And here's the player view. But you can go move my hands around, smooth locomotion. One common issue before I added the hands and any object in the hands layer. So if you held your hand in front of your head, you couldn't move forward. But that doesn't happen anymore. If I hold the gun, I can go ahead and I can fire at these spears on the ground. And then I can also, I made these zero gravity. Patrick added these in. They're kind of like targets. You're supposed to get points, but I never really got that implemented. But they kind of float around. And if you try to walk through, there's a distance variable in the smooth locomotion. I think if I go ahead and go in Unity, if you look at the, oh, it's not here right now, but there's a distance variable under the player, so you can't really get too close to an object, so you can't walk through it. But a lot of speedrunners in Half-Life Alyx will try to go and lean over and push their head through a wall, and you can do that here. If you lean forward, you can push your head through it. Then you have to go around the wall again. You can see the rockets kind of on the ground. Don't know why I left the gun. I think it's I might just have to restart this. Is there any questions?
All right, so for our project, we developed an app that we call Snowball Hustle. Basically, you spawn in a small snow arena with trees, a table, and some snowballs. And you can, this is a VR app on the Oculus Quest, and you can move around, pick up and throw snowballs, which explode if you throw them hard enough. And yeah, you can run into trees and say hi to the giant snowmen on the map. You get started with the demo. See if I can get this working really quickly. So, yeah, gotta redraw my guardian boundary. All right, continue. Sometimes the quest is interesting. All right, can everyone see this?
Yes.
Yes. Nice.
So I'm gonna go ahead and start. So we can move around. Hold on, are we in the app? I don't know how to get rid of them. There we go. So we can move around. These are the snowballs. I can go ahead and pick one up. I can throw it. See if you hit an object. Yeah, if you hit something, you see a little animation. Yeah, if you don't toss it hard enough, the things don't explode. And yeah, there are trees you can run into. Sorry if anyone's saying anything. I can't hear much of anything with this headset on. And you can go in and, I don't know, mess with the snowman if you want. Give him a tap on the head. Then yeah. That's that. So we had some difficulties when developing this app. Initially, we wanted to do some we wanted to try to do some multiplayer, and we had jumping and crouching that were held over from lab 1 that we wanted to keep working, but we didn't manage to do that. Yeah, and VR integration wasn't simple. And yeah, there was a number of things that gave us some trouble, including debugging, because since we were using our quests, we didn't have access to a console there. And yeah, having to learn a complicated program, Unity, and a scripting language at the same time wasn't easy. The Unity documentation wasn't always helpful. Steep learning curve. Long build times, those weren't fun. Times they were actually, yeah, very long, but. And yeah, finding assets that you might need wasn't always easy. I actually had a less than trivial time trying to find these snow assets. And actually, yeah. So ideas for the future, more movement, i.e. the jumping and crouching that I mentioned, maybe some multiplayer, and potentially even live voice chat so you can snowball fight with your friends. That's it.
So for our project, hopefully
are still paying attention, this is the last project here. There's a lot of them, but they've been really awesome. So anyway, we decided to do a first-person shooter firing range. This was our first project ever in Unity or VR, so wanted to try not to go too extreme on it. And so we wanted to create a full 360-degree first-person experience with the Oculus Quest and using Unity to build it. And through that, we have interactable tracking of the Quest itself, so that you can move your hands around and look around properly. We got that working. You can pick up a weapon and shoot it. And so we have the projectiles working there, as well as the collision mechanics for the targets, as well, and something that happens when they collide. And yeah, for the Oculus, we ended up upgrading Unity to 19.4.21, trying to keep up with the latest stuff here. And we used the XR interaction toolkit and just the Oculus asset integration. We tried not to use any of the other interaction setups just to try to keep it as up to date as we could and not use as much legacy things. And that caused a couple issues at times where we had to make sure we had that we didn't have any of that enabled, and a lot of the tutorials were out of date because of that, but we got it working, so that was pretty nice. And so we made 2 demo scenes for this, and the first one was a semi-simple firing range here that I'll press play on while I keep talking. And basically it shows here we can pick up this water gun pistol type thing that actually shoots a bullet. And sometimes it's really hard to hit the targets with it. That was, I believe, a collision mesh issue of the sizing of the target mesh versus the bullets. But when you do hit it, in this case, the targets would fall forward. And you can see that gravity is working on them, as well as physics of the interactions. And we only set up the one weapon, even though there's 3 displayed on the table there. But it's relatively simple to add the other weapons to that. And then we did a second demo. Why is this not skipping screens? Video made that work. The second one was more of like a kind of carnival style hunting type game, using a lot of the similar mechanics, but we have moving targets now that are much harder to hit. And when you do eventually hit them, they disappear. And we had to, play around with the collision mesh quite a bit and the sizing and velocity of things to get that to work. And in this demo, we did eventually hit one of each type of target, but it was extremely difficult with this. That'd require quite a bit of fine tuning to make this an actual game for the public. But you can also see this one is a full 360. The targets are going all the way around behind you or front, so you pick the angle you want and you can shoot from there. If one's not working, you can move around and try a different angle, and sometimes that works better. And a lot of these animations proved challenging in order to get the movement right versus and keep the interaction there. And all the assets in this one, except for the gun and table, we actually made ourselves. So that actually took quite a bit of time. And one of the reasons we didn't get even more done with it is, turns out it takes a long time to make your own assets. And nope, that's just gonna play it again. Go to the next slide. So yeah, the current progress, we had the hand presence and controller tracking, as you saw, movement around, interaction with the objects, projectiles, collisions, everything there that I already mentioned. And let's see. Yeah, there's a lot of different ways to get this interaction working, and the method we used was the XR toolkit built-in components. We didn't want to rewrite things that were already written, and just the complications were just getting those to work with our system. But otherwise, it was a lot of fun to work with. And now Harmandeep's gonna talk about the rest of the presentation here.
If you could keep showing your screen. Yeah.
Mhm.
The rest of the stuff that we did were basic interactions that we did. We implemented XR components, inbuilt components to do that, and basic stuff to grab objects and interact with them. And you can go to the next slide. Yeah. Yeah, and for the gunfire and bullet spawn, we had to write our own scripts for that. We had to trace the muzzle of the gun and spawn a bullet every time we hit the trigger on the Oculus controller. And that's how we generated a bullet every time. And then we implemented a script for the projectile, as it would shoot the projectile directly in front of the muzzle to give that effect. And then could you go to the next slide as well? And then for collision, we just implemented basic physics. As you saw in the first demo, the objects were falling in front of us as the objects were really heavy and the bullets were not that strong. The shooting force was not that great because if we implement a larger shooting force, the bullet would just go through the object. So we had to turn it down a little bit. And for the second one, we just made them disappear. And the next slide. And the things we couldn't get done in time to which we had planned was a scoring system that we planned to make a timed or a number of objects scoring system that you hit so that you can keep track of what you did in the game. Some hand gestures, like you saw, the hands were quite stiff in our model. We couldn't move around our fingers, so that was something we wanted to implement. Teleportation, we could move around in the game, but teleportation was not implemented, so that could be a aspect we could do. And the speed of the moving targets were quite high, so it was really tough for us to hit the targets. So that was one thing. Yeah, and a reset system for the first demo that we did. As the targets fell down, we had to restart the game to get the targets back on. So we had to implement that. So these are some things we couldn't do in time. And difficulties, yeah, difficulties. There were a lot of difficulties. Unity is a difficult software in itself. Writing the scripts and getting to work, it's really hard. Oculus deployment was a really big issue for us as well, as we were on different versions of Unity, so it worked differently than if you install the XR interaction toolkit, then it wouldn't work with the legacy stuff, and if you install the legacy stuff, it wouldn't work with the XR interaction toolkit. So we had to manage that up. Network connections were a problem, as if you have a lower network connection, low internet speed, so it wouldn't track your hands properly. So the bullet would spawn at a prior location where your hands were, and it would come out of a space that's not exactly the muzzle of the gun. Coding the scripts was not that bad, but yeah, took some time. And yeah, testing the game again and again, every time you implement an aspect and then you have to test the game, then you put on the headset, then you put it down, then you again test the game. It really made my head spin personally after a while. And tips, if you really want to go into VR production, you have to be patient with Unity. It will show you some really crazy bugs that you really don't want to see. It will make your head spin with stuff. It's really bad in that scenario. And yeah, we created our assets ourselves, so that was a really big hurdle that we did. But you could download the assets online, and that's pretty easy and useful. And but scripting everything yourself is much better, as you have more control over the mechanics of the game. So that's a plus point. And yeah, final and the biggest is always save your project, because it would crash. It would crash a lot of times, and all the progress you did would be gone. So save your project. That's a really big tip. And thank you. And we're up for questions.